receptors have the following characteristics, regardless of whether they are thermoreceptors, pain receptors, all those receptors that we have looked at, all of them have these properties. These properties apply to all of them. The first, which is often very obvious, because if you know the definition of what a sensory receptor is, then you just know that they pick information about the surrounding, whether internal or external, and convert that information into electrical impulses and then sent to the brain for interpretation. And that process is what we call transduction. So we are saying that all sensory cells pick information, and then that information comes from particular stimuli, and then send that information to the brain via electrical impulses along the afferent nerves. And then we have specialization. Remember when we talked about the shape of a receptor? The shape of the receptor is one of the things that actually determines the fact that these receptors are actually very specific. The receptor for pain cannot detect changes in pressure. Changes in pressure are detected by baroreceptors in this case. So that means that's why we actually have all these different types of receptors. And then we have what we call generator potential. We will see that for transduction to happen, you need to have the information exceeding a particular threshold or threshold value. This is basically to say that if the stimuli is not very strong, then you cannot have an electrical impulse being fired. Okay, that information is not sent to the brain. So that means that you can have localized electrical charge, but that charge, if it is not reaching the threshold, then it will not fire. So it will remain as a generator potential. So that's what we are talking about in terms of point number 3. So the threshold is that specific stimulation that is required for an action potential. The meaning of this is that you cannot have an action potential or an electrical impulse if the stimulation is not strong enough to reach the threshold. That is the minimum level for you to be able to fire the electrical impulse. And then point number 5 is about the fact that when you stimulate these sensory receptors, they will respond as long as you reach that threshold. But continuous stimulation, even above the threshold, will not give you the same extent of the response. You have diminished response with the time from the receptor. So that is what we term as adaptation, that over time you have the response actually declining, even if you have stimulus that is exceeding the threshold. And then these receptors can actually be inhibited, meaning that they can be stopped from working. Okay, that is inhibition. Inhibition can be because of certain chemicals that are antagonistic. It can be because of drugs. Drugs that are antagonistic, for example, it can be because of poison. And remember that these sensory receptors are actually connected. You have different neurons that connect to convey this information to the brain. The connection between these neurons is what we call the synapse, and therefore that means that the point of transmission between at a synaptic connection, you can still have inhibition there, and still that can give you what you can call a selective response. Okay, we'll move to point number 7. The point number 7 is that these receptors can give what you call detailed information about the stimulus. Of course, we are saying that every sensory receptor can pick particular information. So they are very specific. But after picking that information, we need, or the brain needs a lot of information about that information that has been sent to it. For example, if it is sound, where is the sound coming from? Which direction? Now, what is the intensity of the sound? Can you actually also associate the sound to something that you know? Okay, so that means that um, sensory receptors give a lot of information or pass information um, to the brain about the stimulus that we are talking about here. Receptors are generally very sensitive. This is to say that you don't need to overstimulate them for them to fire electrical impulses. Okay, so that means that they are actually very sensitive. That's why even in low light, even for example, for for the roads, you can still see. You can still be able to see. That means that the roads are actually very, very sensitive in terms of detecting light, even in situations where the light is very minimal. Okay, so like the last one is always don't forget that these sensory receptors are connected. They are connected to other neurons that will relay this information. So that means that generally you will have the cell body, the dendrites that connect to other neurons.